Welcome to Lesson 2. In this lesson, we're going to write, graph, and analyze cell phone costs. We are going to write piecewise functions to represent cell phone plans because those plans typically follow a piecewise format. We are going to then graph and analyze a piecewise function, and we'll do a little extra practice with graphing at the end. All right, let's get started with our first scenario. So in this scenario, we have a phone company that has many different calling plans. They have a basic charge per month, which includes a number of free minutes, and that's pretty typical. Then there's a charge for each additional minute. This piecewise function below gives you the price, and the price is represented by y, or f of x, of an x minute plan. So x represents the number of minutes. Fractions of a minute are charged as if they were a full minute. So if you go over by 30 seconds, then you're charged as if you had a full minute, and that's what this bottom one is. So let's look at this. Let's remind ourselves. What is this 40? This 40 stays constant in all three situations. So the 40 would represent the basic charge per month. And then let's look at the 0.35, the 35 cents. That represents the charge for each additional minute, right? So if we look at our scenario up here and what it says, we have a charge for each additional minute, and that's what that 35. And then we have something a little bit unusual here where it says fractions of a minute are charged as if they were a full minute. So here this +1 turns it into a full minute at this price. So notice then our domain. We use the first equation when the number of minutes is less than or equal to 750. We use the second equation when the number of minutes is greater than 750 and the number of minutes is an integer. Remember that an integer is a whole number, like 1 or 2 or 3 or 4. Something that is not an integer would be 1.2. So if you talked on the phone for 1.2 minutes, that would not be considered an integer. That would be considered not an integer. So you use this last equation when the number of minutes you talk on the phone is not an integer. It's over 750 and it's not an integer. So let's look at some examples. So let's say A. Let's just say you talked on the phone for 750 minutes. So which plan would you use? 1, 2, or 3? So you would use number 1. So the cost that you would pay if you talked on the phone for 750 minutes or less, you would pay $40. So let's do another example. Let's say you talked on the phone for 800 minutes. So then you would need to pick which equation you use. Well, 800 is an integer, so we would use this middle one because we are over than 750 and x is an integer. So the way we would calculate it is we would pay, so our cost in this situation would be the $40 plus we're going to pay 35 cents a minute times however many minutes we talked minus 750. So if we do a little math, we say that we will owe $40 plus 35 cents times 50 minutes is what we went over. Okay. If we multiply that out, 35 cents times 50 minutes, we get an additional $17.50 added to our plan fee, which is 40, so we would pay $57.50 in this situation. So let's do one final example. Let's say we talked on the phone for 760 minutes and 30 seconds, so 760.5. So let's figure out our cost for that. So in this situation, we would use our third equation because now 760.5, right, 30 seconds is half of a minute, is not an integer. So we would take our cost and say that we're going to pay $40 plus that 35 cents a minute times however many minutes we talked minus 750 and then we add plus 1 because we don't want to leave it as a fraction. And I'll show you how this will look. If we take 765.5 minus 50, we get 15.5. But what we really want to do is round up at the end. And again, this is all, and I'm doing my parentheses incorrectly here. Let's just fix that. So what we want to do is take 15.5 plus 1, and we would get 40 plus 0.35, and we're going to add a minute because that's what it says. Fractions of a minute are charged as if they were a full minute. So we are going to take this and make it 16.5, and then we can do our math. So I get $5.77 5/1000ths of a cent here, and if we add 40 to that, and then of course we want to make it realistic, we would pay, if we rounded, $45.78. Okay, so that's how you analyze a piecewise function, in case you've forgotten. Now let's go ahead and create our own as well as graph it. And that's a new concept for you to be able to graph a piecewise function. So let's look here. Horizon Cellular charges a flat fee of $32 per month for unlimited calls and 400 text messages or less. So here's our key, 400 text messages or less. If the number of text messages exceeds 400, now we have a different equation. There is an additional fee of 11 cents per text. So we want to write and graph a piecewise function to represent that. So we're going to have two parts to this. So our first part, we know we're going to be charged a flat fee of $32 when our text, so when x is 400 or less, so less than or equal to 400. That's what it states in our problem. If we text 350 texts a month, we pay $32. If we text 400 texts a month, we pay $32. If we go over, so when, in this situation, when x is greater than 400, we have a different schedule. We still pay the $32, plus we're going to get charged 11 cents on anything over 400. So if x is our text, x minus 400 will give us the number of minutes that's over 400, and we're charged 11 cents on that. So those are our two equations that we want to graph. So what I'm going to do is take these equations over to our graph, and I'll show you how to do this. Okay, here are our two equations. I can graph y equals 32. That's just a horizontal line where y equals 32. But what about this bottom one? It's pretty long and complicated, so what I normally would do here is make a t-table. So how do we know what numbers to plug in for x in order to solve to get y? Well, we use this when x is greater than 400. So let's just start at 400. We always start at that point and plug that in. And then let's pick another point. And it doesn't matter, but usually we want to pick a point that's a little bit farther away so we can get a good line. We just need 2 points to make our line. Okay. So if we plug 400 into this equation, 400 minus 400 is 0. 0 times 0.11 is still 0. Plus 32 is 32. So that's pretty easy to figure out. Same thing with 500. If we plug 500 in for x, 500 minus 400 is 100. 11 cents times 100 is $11. And $11 here plus 32 gives us 43. So it's as simple as that. Now we just need to label our graph and put some scales on our axes. Well, we know that x is going to be the number of texts, so we would write this here. And we know that y is going to be our total cost, so we would write this here. All right, now we just need to make a scale. When I look at my scale, I know that my x's have to go up to 500, but my y's don't have to go up that big. So if I'm going to make a scale, maybe I would go by 25s here on the bottom, and perhaps maybe I would go by 4s here for my y-axis. I've gone ahead and labeled my scales, so now let's graph this first equation. The easiest way to graph a piecewise function is just to graph it like you normally would initially. So this first one is y equals 32. So I go to the 32 right here, and notice I don't have any negative numbers because that wouldn't make sense. So I go to the 32 and I would graph. I would make a horizontal line and that would just continue on forever. And that's the graph of y equals 32, and it technically mathematically is going this way as well. We just aren't showing the negatives. Now the only thing I have to do now is adjust it. So I only want to see this graph when x is less than or equal to 400. Well, here's 400 right here. Right? I'll circle it right here. So I don't want to see anything going this direction here because it says I only want to see the x's when they're less than or equal to 400. So then what I would do is I would erase all of this that's to the right of 400 because I don't want to see that. And since my inequality says less than or equal to, remember that I can put a solid dot here to represent this value. Okay, great. I have now graphed this first one. This second one's going to be easy for me to graph as well because all I'm doing is graphing 2 points. I'm graphing my initial point here at 432, which is just right here. And my second point is at 500, which is here, and 43, which I put in a 40 and a 44 so we could estimate. It's about right here. And then I would just connect that line. Notice I have an open circle here at 400 because my second equation just wants to see the graph when x is greater than 400. So I don't really include the 400 for my second graph. But notice that it was easy for me to graph it because my first point started here at 400 and then I just picked another random point. So here is my graph of the piecewise function for that cell phone plan. And you can see then, if you analyze it, what's going on. My costs stay consistent, they don't change. But then as my minutes go over 400, you can see that now I have a slope. It rises. And we could actually calculate this slope. Remember, it's rise over run if we wanted to. The other thing we could do is we could take our equation here and we could simplify it. We could actually turn it into y equals mx plus b by distributing the 11 cents into the parentheses and then combining like terms. But either way, whatever's convenient for you is how you should graph these piecewise functions. We're going to try one more just to practice before you try it on your own. So here's an example where we have two piecewise functions. And these are set up as y equals mx plus b already. So if we look at our first one, we have the equation 2x minus 1. So y equals 2x minus 1. And in this case, we have negatives here. So let me adjust and put in a different graph. Okay, and these are just to practice. So in here we have a y-intercept of -1, if you recall how y equals mx plus b works. So we have -1, and we have a slope of 2 over 1. So we go up 2 over 1, up 2 over 1, and we have our equation. Now we can come through here and we can just draw the line straight through if we want, initially. And then we can determine how much of it we want to see based on this domain. So we only want to see the parts where x is less than or equal to -2. Here's -2. So if I come down here and make this, we only want to see this part down here, and I'll highlight it in orange. We only want to see this part down here. We don't want to see the rest of it because that's greater than -2. So we only want to see this part down here, the orange part. So I would just take my eraser and I would erase all of this. All right. And then at this starting point here, I can put a solid point because it's less than or equal to. Now, just to be consistent with the way we did the other one, what I'm going to do is I'm going to create a t-table for this. In this case, it says I only want to see this graph if x is greater than -2, so I'm going to start with a -2 and plug that in. So if I plug in a -2 into my equation, -2 plus 3 is +1. Now I just want to pick another point that's greater than -2, so I'll go ahead and pick 0. That's pretty easy. If I plug in a 0, I get 3. So my first point is here at -2 1 right here, and I'm going to put an open circle because I don't really want that point. I want greater than that point. And then I'm going to put another point here at 0, 3. So my graph would look like this. And in this case, these aren't connected, but this is also an example of a piecewise function and how you graph it. Okay, that concludes our lesson today on piecewise functions, how to analyze them, graph them, and evaluate them.